Welcome to the notes for Chapter 3, Section 4, double angle formulas. So, in order to get those double angle formulas, once again, like we kind of did during the last lesson, we're going to have to use the composite properties where we just add a plus a, and we'll just turn that into 2a. So the rule for sine of the sum of an angle is sine, cosine, cosine, sine, using the same sign with a g. So the sine of a times the cosine of a, since the second a is our b, plus the cosine of the first a times the sine of the first a. But sine times cosine and cosine times sine are really the same thing. We could write that as the sine of a times the cosine of a plus another sine of a times the cosine of a. And altogether, we would get 2 times the sine of the angle times the cosine of the angle. The tangent of a double angle, tangent of 2a, would be the tangent of a plus the tangent of b, but there is no b, so we have just another a, over 1 minus the tangent of a times the tangent of b, but again, there is no b, we just have another a. So we can simplify that one to the tangent of a plus the tangent of a is 2 times the tangent of a over 1 minus the tangent of a times the tangent of a is the tangent squared of a. Again, these are the rules that we had figured out in the previous lesson. So the cosine of 2 times any given angle, since we have the cosine pattern is cosine, cosine, sine, sine, we have the cosine of angle A times the cosine of angle B, but again, there is no angle B this time, it's another A, minus the sine of angle A times the sine of angle B, but again, just an A. Cosine times itself would be cosine squared minus the sine squared. Now again, because sine squared plus cosine squared equals 1, we could actually replace a few, we could turn either all the cosines into sines or all the sines into cosines. So in terms of cosine only, the cosine of 2 times an angle, we could turn into the cosine squared of an angle minus, so sine squared can be 1 minus the cosine squared. We can distribute that negative, which would turn the 1 negative and the cosine squared positive. So we get 2 times the cosine squared of the angle minus 1. Similarly, to turn it only into sine, cosine squared is 1 minus the sine squared minus another sine squared. Since there's nothing to distribute, we don't really need these parentheses. 1 minus, minus the sine squared minus another sine squared would be 1 minus 2 sine squared of the angle. So again, we can use the unit circle and what we know about particular values of functions to practice with these. Here, let me change my lighting a little bit. Yeah, that's a bit better. Again, this is the final rule for the cosine of 2 times an angle, or you could use either of these for cosine of 2a. So the find the sine of 2 times an angle given that your angle is 30 degrees. So we're just going to apply these formulas and rules right here. So we're looking at the sine of 2 times 30 degrees. And according to the rule that we just found, that'll be 2 times the sine of 30 times the cosine of 30. So that should actually get us the sine of 60 degrees, which we could also look up on the unit circle. We'll do that in the next step. But the sine of 30 is 1/2, and the cosine of 30 is root 3 over 2. And we'll pull this up here for the next part. The 2 and the 1/2 cancel each other out. And again, we'll look at the unit circle to find out that the sine of 60 degrees is root 3 over 2. And the sine of 2a that we started with is actually the number that we thought it should be. We can do the same thing with the cosine formula. So the cosine of 2 times a 30-degree angle is going to be the cosine squared of the 30 minus the sine squared of the 30. Again, that kind of means that we're looking for the cosine of a 60-degree angle, which, if we look up on the unit circle, should be 1/2. We also look up the cosine of 30 is root 3 over 2, and that's going to get squared, minus the sine of 30 is 1 over 2, which is also going to get squared. Again, let me pull this up here for the next part. Cosine of 60 is 1/2. Root 3 squared is just 3. 2 squared is 4. 1 squared is 1 over 2 squared is 4. 1/2 equals 2/4. And then we can make that say that 1/2 is the same thing as 1/2. We can do the same thing in radian mode. Find the cosine of 2 times an angle, given that our angle is pi over 4. So the cosine of 2 times pi over 4 is going to be the cosine squared of pi over 4 minus the sine squared of pi over 4. Remember, pi over 4 is like a 45-degree angle. So 45-degree angles, pi over 4 angles, have root 2 over 2 as their sine and cosine values. So we could simplify this, or we could notice that we have something minus itself, which is going to become 0. But let's go back and simplify the cosine first. Again, 2 times pi over 4. The 2 and the 4 can cancel down, so we're actually looking at the cosine of pi over 2, which we know is like a 90-degree angle, and the cosine of 90 is 0. Let's do the slower simplification here. Root 2 over 2 squared. Root 2 squared is just 2 over 4 minus 2 over 4, and that means that 0 is the number that we are looking for. Example D. Find the sine of a double angle, given that we're working with pi over 4. So again, the sine of 2 times pi over 4 is going to equal 2 times the sine of pi over 4 times the cosine of pi over 4. Again, from the unit circle, we know that the sine and the cosine of pi over 4 are both root 2 over 2. From the previous example, we know that 2 times pi over 4 is really pi over 2, so we're really taking the sine of pi over 2. And again, going to the unit circle, the sine of pi over 2 is 1. Simplifying here, we can cancel out a multiplying by 2 and a dividing by 2. Root 2 times root 2 is 2 over 2, and 2 over 2 is 1. Next example, we're going back to degree mode. So find the tangent of 2 times 30 degrees. Sorry, 2 times 60 degrees. That'll change it a little bit. So the tangent rule is that we will have 2 times the tangent of 60 over 1 minus the tangent of 60 squared, or the tangent squared of 60. Again, 2 times 60 means we're actually looking at the tangent of a 120 degree angle. I'll just work, since this is a fraction, I'll work up here a little bit more. The tangent of 60 is either going to be root 3 over 2 divided by 1/2, or if you've got the chart memorized, we can just simplify that to root 3. So 2 times the tangent of 60 would be 2 root 3 over 1 minus root 3 squared. The tangent of 120 we can look up in a second. We can simplify a little bit first here. So 2 root 3 over 1 minus root 3 squared would just be 1 minus 3. 1 minus 3 is negative 2. And those can cancel out, and we get the opposite of root 3. Looking up the tangent of 120, either by dividing negative root 3 over 2 divided by, or sorry, positive root 3 over 2 divided by negative 1/2, or again by finding it in a chart, negative root 3 is actually what we're looking for. So negative root 3 does equal itself. Then finally, find the tangent of 2 times an angle, given that our angle is pi over 4. So again, tangent of 2 times pi over 4 is going to equal 2 times the tangent of pi over 4 over 1 minus the tangent squared of pi over 4. 2 times pi over 4, we already found out, is pi over 2. But that's kind of a familiar number, or a familiar set of terms. The tangent of pi over 4 is 1. So we get 2 times 1 over 1 minus 1 squared. The tangent of pi over 2 would be 1 divided by 0, sine divided by cosine. And 2 times 1 is 1 over 1 minus 1 squared is 0. So this does not exist because this is one of the places where tangent has its vertical asymptote. I'll see you for the next part in the next video.